do as a part of the estimation process. So on a broader aspect, I'm going to talk about the different needs for sampling, as well as different ways in which the sampling can typically be done. Then, moving towards the world of estimation, there is a very important theorem that plays an important role, which we call as the central limit theorem. So I will try to touch base upon that central limit theorem, and how would it be helpful for us as a part of our estimation process. Then we talk about the two different types of estimates that we do for the population mean. So we are discussing about the estimation of the population mean and two major estimation mechanisms. One is a point estimation and the second one being an interval estimation. So we'll talk about those two kind of processes, and finally we would try to see what are the typical biases that are possible while doing a sampling. So these are the different things that we have to keep in mind. First of all, so just to get started, see, typically we observe, let's say when I talk about a Sensex, or I talk about DJII, Dow Jones Industrial Average, we all know that they are the market indexes, right? They are the market indexes. They are based on the market capitalization of a few stocks which are listed in that particular country. A few stocks, 30 stocks that are listed here, also 30 stocks that are listed. So there is some kind of a calculation that is performed on these stocks, and a Sensex as an index is computed, let's say on a daily basis. Now, this Sensex or this Dow Jones, this S&P 500, none of these indexes, they do not include all the stocks that are listed on that particular exchange. They do not include all the stocks. They only represent a few. But just by understanding those few, sometimes we make conclusion about the entire market. If the Sensex has gone up, we may say the whole Indian market, Indian stock markets are up. So just by looking at the numbers of few of the stocks, we are making a mention that the entire population, entire market is in the upward direction. So that is where we are looking at the companies which are a part of the Sensex or companies which are a part of the Dow Jones as the key indicators of the entire population's behavior. So this is what we call as a sample. Sample is a subset of a population. By doing some kind of analysis on the sample, we are estimating the behavior of the population. By doing some kind of calculations on the sample, we are estimating the behavior, or we are estimating the behavior of the entire population. So that is what is the concept of sampling all about. So here for us the most important things is, first of all, how to do a sampling. So what do we mean by sampling, and what are the ways in which sampling can be done, and how can this sample information, sample calculation, whatever we are doing, how can I use it in the estimation of a population parameter. If I have to estimate the population mean, how can I use a sample for doing those kind of estimations? So this is what is a very important aspect that we are going to look at. So just to get started with the fundamental of sampling. So the intention behind the sampling is come out with information about the entire population or select a few elements of the entire from the entire population using a different sampling procedures and do some kind of a computation. So the computation that we perform on the samples we call as statistic. So use those statistics to estimate the parameter. Parameter is something that describes the behavior of the population. So generally, even when we have a population of the data, we still rely on the sample. Why so? In one case, probably the whole population, I don't even know what is the whole population. And it's very difficult to really get each and every data of the entire population. Or in some cases, though I know what is the whole population, probably the cost that is involved in getting the whole data is pretty expensive. So it's nowhere efficient economically. So by getting into the sampling process, we are really saving on time and money. That's one important dimension of sampling. So when we are discussing the sampling, I talk about two major mechanisms right now, though there are so many varieties of sampling, but the most commonly used ones which are going as a part of selecting a sample at random. So within that we talk about a mechanism called simple random sampling, and the other one is a stratified random sampling. The two are heavily used in the finance industry or for many other industries as well, the simple random as well as the stratified random sampling. Now, when I look at, let's say, my entire population, this is my entire data, and out of them I have selected these values at random, and I have computed the sample mean for these particular values. Taking these particular values, I have computed the sample mean. So whenever we talk about the population mean, we represent it by mu. Whenever we talk about the sample mean, we represent it by x bar. Now, what is the advantage of just collecting this sample? We have already said one, we can save on time, the other we can save on cost. But at the same time, there is a possibility of an error when I have to predict the population mean, because I did not consider all the elements of this population. There is a possibility of an error. So which means this is a kind of striking the balance between the time and cost, versus the error. I may save heavily on time and cost, but it can induce an error. So my intention is to what extent I can optimize this particular scenario, and that is where we are coming out with what we call as a sampling plan. A sampling plan clearly lists out the details about what is the type of sample we are going to go with, what are the rules that are driving the selection of the sample. So when I talk about a simple random sample, it's like this. So I'm selecting a sample, let's say whatever is the size of this sample. This sample is selected in such a way, let's say if this is the population, every element of this population, has equal chance of being included in the sample. Means probably if the population is of size 500 but I am selecting a sample of size 50, any one out of these 500, any 50 out of these 500 can very well be selected into the sample. So that is what we are calling as simple random sample. So every element of the population has an equal chance of being included as a part of the sample. So which means everything is random. The way in which an element gets added to a sample is completely random. So I can use the random numbers which are there as a part of various tools, use the random number generators, computer based or random number tables that are available, use them to randomly pick the X items out of the N items which are there as a part of the population. So that is one way going as a part of simple random sampling. But slightly an improved version of the simple random sampling is the systematic sampling, especially when I'm not able to randomly assign numbers to each one of them and pull the values. What I can very well do is I can follow a systematic procedure. Now that I require 50 elements out of the 500, at random I'll pull out the 10th element. At random, I'll pull out the 10th element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is included in the sample. So every kth number is being included as a part of a sample until we have the sample of the size which we are looking at. Right? So that is a way of sampling which is a systematic sampling. Now, whatever is the sample that we have collected, we will compute the sample mean. And what we are saying is the sample mean will provide an estimation towards the population mean. Though I don't know what is the population, though I have taken one subset of that particular population, computed the sample mean, we'll be looking at it slightly later, where we say that sample mean provides a decent estimation of a population mean. And wherever these two things differ, the difference between the sample mean and the population mean is what we are typically calling as the error because of the sampling, and we are treating it as a sampling error. So it's a difference between the observed value through the sample and whatever the corresponding value that we want to estimate for the whole population. The difference between the two is what we are calling as sample error. And whenever we are talking about a random sample, because we are selecting the data at random, all the properties of the population will be represented completely in a neutral and an unbiased manner. That's one of the prime reason we say the sample selection, whether it is simple or stratified, it has to follow a random kind of a process. Then only the behavior of the population will be represented in an unbiased manner. And what we typically have to introduce now is whatever the statistic we are computing, let's say sample mean. The sample mean is not a single value. Let's understand. It's not a single value, rather it's a distribution. The most important driving piece for us here. The sample statistic is not a single value, it's a distribution. It's actually a random variable, because what is typically happening is out of this 500,